Okay, question 7. Solve for x, y, and z. So this question, 1 over x plus 2 over y plus 1 over z is equal to 1. Okay. So you can use a substitution. So at the first glance, this is not a solvable question, right? Because all your x, no, it's not 1 times x, right? It's 1 over x. It's not 2y, it's 2 over y. So at the first glance, it's unconventional. It doesn't look like we can apply the Kramer's rule. Okay, but here we can do something, right? We can do a substitution and then make it, right, make it solvable by using the Kramer's rule. So we can simply set 1 over x to be, let's call it a, okay? Let's set 1 over y to be b and 1 over z to be c. Okay, then you do the substitution. Now it's a plus 2b plus 1. Right, sorry, plus c is 1. Right, 3a plus 4b plus c is 5. So 8a plus 6b plus 7c is 0. So then you can apply the Kramer's rule, right? You can rearrange, you can put all the coefficients together. You can put all the coefficients together. Okay. And solve ABC by the Kramer's rule, right? A, okay, so let's call this matrix A. So A is the determinant because A is the first variable, so you replace the first column with the right-hand side. So the first column will be 1, 5, 0, and the other two columns just copy down. Okay, 2, 4, 6, 1, 1, 7. Okay, this is the determinant, and over the determinant of A. Okay, determinant of A. So here, in previous questions, we have done a lot of calculations of the determinant. So here I skip all the details. Maybe just once here. Okay, so for a determinant, you need to find a row or find a column to get the determinant. So let's just say we pick the first row. Okay, so it will be 1 times the determinant of, you delete this row, delete this column, the remaining thing. All right, 1 times the determinant of this. Okay, minus 2 times the determinant. Okay, so it's always plus minus, right? If you choose the first row. Okay, let's write down the complete formula so you're not confused. So it's actually 1 times negative 1 to the power of, because this 1, it is a 1, 1 entry, right? So it's negative 1 to the power of 1 plus 1 times this. So this part is positive. Okay, then minus 2, okay, 2 times negative 1 to the power of, right? Because this 2, it's a 1, 2 entry. So negative 1 to the power of 1 plus 2 times, you delete this row, delete this column, 3, 1, 8, 7. Okay, 3, 1, 8, 7. Right, then the last row, it's plus 1 times negative 1 to the power of 1 plus 3, because this is the 1, 3 entry. Right, times, you delete this row, delete this column, 3, 4, 8, 6. Okay. Right, then, so it's 1 times 1 times, here it's just this diagonal minus this diagonal. So it's 28 minus 6, it's 22. Right, minus 2 times negative 1 times, here it's 21 minus 8. Right, 21 minus 8 is 13. And plus 1 times, here it's 18 minus 32. 18 minus 32, it's negative 14. Okay, so it's 22 plus 26 minus 14. Right, there must be some mistake here because it's different from the answer. Let's see. right? I can't find the mistake. Let me see, maybe I copy something wrongly. No. Oh yeah, yeah. If I put -1 here, I should use plus, right? So it's plus. Yeah. So you don't do it. So it's either, you just plus minus, or you write down this -1 to the power of, okay, and always plus. So you either always plus and write down that -1 to the power of I plus j, or you omit this part and you just plus minus, okay? Don't do them at the same time. So now I get the answer. It's -18, okay? So -18, okay, it's not 0. All right, it's not 0, which is great, right? We only apply the Kramer's rule if the determinant is not 0. Okay, so that's how you can get A. So you do the calculation of the top. Right? I will leave it to you. So it's -18 over -18 is 1. Okay, so A is 1. So what about B? B, it's a second variable, so you replace the second column with the right-hand side. So it is 138, 150, 117, okay, over the determinant of A. Right, then similarly, you do the calculation, it's still -18 over -18. Okay, so it's also 1. What about C? C is a third variable, so you copy the first two columns of A, and then the third column of A becomes the right-hand side column vector. Right, this is on the top over the determinant of A. Okay, over the determinant of it. So it's going to be 36 minus over -18, so it's -2. Okay, so now you get ABC. Then the last step, right, because your 1 over x is A and your A is 1, so your x is just 1. Right, 1 over y, it's B, and you know it's 1, so y is 1. Okay, and your 1 over z is C, and it is -2, so your z is -0.5. Okay, so you can use a substitution, and then you can apply the Kramer's rule.